Let's start with the chain rule. If y equals f of g of x, then dy by dx equals f prime of g of x times g prime of x. In plain words, you take the derivative of the outer function, leaving the inner function untouched inside it, and then multiply by the derivative of the inner function. An equivalent way to write this is with u as the inner piece. If y equals f of u, and u equals g of x, then dy by dx equals dy by du times du by dx. This is exactly the same rule, just with a substitution letter for the inner function. Now, implicit differentiation. Sometimes y is not isolated on one side of the equation, so we differentiate both sides with respect to x, treating y as a function of x. Every single term that contains a y will need the chain rule applied to it, and that will produce an extra factor of dy by dx. Let's see this in action with a worked example. We want to find dy by dx for the circle equation x squared plus y squared equals 25. We start by differentiating both sides of the equation with respect to x. That gives us derivative of x squared plus derivative of y squared equals derivative of 25. The derivative of x squared with respect to x is simply 2x. That part is just ordinary differentiation, no chain rule needed. The derivative of y squared is where the chain rule comes in, because y is itself a function of x. So we treat y squared as the outer function, something squared, with y as the inner function. That gives us 2y times dy by dx. Notice that extra dy by dx factor. That's the whole point of implicit differentiation. On the right-hand side, the derivative of the constant 25 with respect to x is just 0. Putting it all together, we assemble the differentiated equation 2x plus 2y times dy by dx equals 0. Now we solve algebraically for dy by dx. Subtract 2x from both sides to get 2y times dy by dx equals negative 2x, then divide both sides by 2y. The 2's cancel and we're left with our final answer, dy by dx equals negative x divided by y. Here's a useful trick for spotting the chain rule before you even start differentiating. Look at your expression and identify the outer function and the inner function. Mentally underline the inner function first, then differentiate the outer function with the inner function still plugged in, and finally multiply by the derivative of that inner function. Now, the most common trip-up in implicit differentiation. When students differentiate a term like y squared, they often write just 2y, forgetting to attach the dy by dx factor. This happens because y squared visually looks just like x squared, so it's tempting to differentiate it the same way. But remember, y is a function of x, not the independent variable itself, so the chain rule must apply, and the correct derivative is 2y times dry by dx, not 2y alone. Finally, here's a teaching tip to help avoid that error. Before you differentiate anything, physically circle or highlight every single y term in the equation. This visual flag reminds you that each circled term needs an extra dy by dx factor when you differentiate it. Do this circling step every single time, even on easy problems, so that it becomes an automatic habit and you never accidentally drop that crucial factor.